you've ever heard. Okay, what do you remember about inverse function? Anything at all? Okay. Inverse functions. What do you remember? Zero things? Don't remember nothing? Okay. So maybe switching your X and Y? Yeah, so switching X and Y. And not necessarily the signs, but do you remember how we had to reflect across the Y equals X line? There was a reflection across there because these are the things you're writing down on your paper. So switching the X and the Y and reflecting across the line Y equals X. You're talking about transformations. But I guess you could incorporate that in there. Another thing that for inverse function is this notation. We have the inverse function of f. Okay, it's that f to the negative first power, right? So again, this is just kind of to jog your memory. Okay, so we're going to revisit the concept of inverse functions, including notation using exponential and logarithmic functions. Okay, so we got a new function. Yay! No. Okay, so on the left-hand side, what is that function called? On the left-hand side, what's that function called? 2 to the x. Not a linear, not a quadratic. Anybody remember what it's called? Nobody knows what this is called? No? Okay, so where is x located? In the exponent, right? These are called exponential. So if the x is in the exponent, this is called an exponential function. Okay, so we got 2 raised to the x. And we got this function. Over here, we have something called a logarithmic function. Okay, so this is the new one. These are the inverse functions of exponential. So logs are inverse functions of exponential. Well, how can we tell that? Well, if we have the line y equals x and we draw it, aren't these two lines reflected over that line y equals x? Yeah, right? Kind of turn your head to the side, squint a little, it kind of looks like a butterfly, right? So what do you notice kind of between these two functions? Is there anything that they both share? Is there anything in that equation that they both share? What's the number that they both have? 2. Okay, so this has a 2 and this has a 2. Okay, what this is called is base raised to an x. What this is called is a base. Okay, base. It's just what? Yep. So we've got log of base, and then we've got an x. And we're going to talk about that a little bit more in just a second. What do you notice between the x and y over here and the x and y over here? They're flipped. Just like we see with inverse functions, right? We switch our x and y. So these are flipped with these, right? Okay, so we kind of already talked about this, but what do you notice about the tables? Well, we said that the x and y's are flipped from each other. Okay, what do you notice about the points on the graph for each function? Well, they're reflected across the y equals x line. Okay, so these are flipped. The x and y switch. And then what do you notice about the points? They're reflected across y equals x line. And then how can we use our understanding of exponents to help us graph a logarithmic function? And y'all have already said it. We could switch x and y and plot. Whole entire world, key features, yay! Okay, so looking over here, we've got an asymptote at y equals 0. Just a reminder, asymptotes are where the line approaches but never touches. So we got a line at y equals 0. The domain is going to be all real numbers, and the range is going to be y is greater than 0. Okay. The x-intercept is 0, 1. That's not true. These should be flat. Go ahead and correct this on your paper really quick. This right here, there is no x-intercept. And right here, 0, 1 is the y-intercept. So go ahead and correct that on your paper, because that is not correct. Okay. All right. So for logs, thanks, babe. Remember, logs are inverses of exponential. So basically what's going to happen is you're going to flip-flop your x and y's. Okay, so watch this. The domain, the asymptote is going to be now a vertical asymptote at x equals 0. So right here, there's going to be a vertical asymptote. The domain is going to be x is greater than 0. So notice how there's only x's on the right-hand side. There's nothing less than 0. The range is going to be all real numbers. That means I'm going to have a number for every y value. There's going to be a point. There's an x-intercept at 1, 0. Yeah, what's up? Well, look at how the exponential is. And we said that these are inverses of each other, right? So if all real numbers is going to be the domain, for the inverse, it's going to be range is going to be all real numbers. Yeah, because we're going to switch our x and y's.
In the graph, you don't see that the graph is going from negative infinity to positive infinity for the y. So this is all of these numbers. The ends of the graph.
It would keep going on forever. Yeah. Good question, though. And then we're going to not have a y-intercept. Okay, so again, notice how I flip-flopped everything that's on the left-hand side. So everything's on the right-hand side. We flipped them. Okay, this guy's going to have that horizontal asymptote. And this one is going to have a vertical asymptote. It's one thing to particularly pay attention to. We've got some key features. So we're going to talk about increasing, decreasing, and in behavior. Okay, so on this side, is this increasing or decreasing on the left-hand side? Increasing, right? Is it ever decreasing? No. Okay. What about the in behavior? Well, as x approaches positive infinity, y is going up to positive infinity. As x is going to negative infinity, y is approaching 0. Okay. Over here, is this increasing or decreasing? Is this increasing or is this decreasing? On the left-hand side, like if you're on a roller coaster and you're on here, would you be going up or down? Going up, right? And where is that increasing from? Well, what's our x value to the farthest to the left? 0. Okay, and how far to the right does it go? Infinity. Does it ever decrease? No. Now let's talk about in behavior. What? Why do you put 0 instead of like negative infinity? Well, does it go on anywhere to the left? No. What's our farthest left x value? 0, right? So we're going to say from 0 to the right, we're going to have numbers. For in behavior, we're going to say as x approaches positive infinity, so as we move to the right, where's our y going? It's going up, so we're going to positive infinity. Now here's the tricky part that people mess up on. As we go to the left, we're actually just going to 0, right? And where is that going towards? Well, it's going to negative infinity. Okay, so as we move to the left, as x approaches 0, we're going to negative infinity. Okay, so notice how the in behavior kind of flip-flops, right? It kind of switched. The increasing intervals kind of changed just a little bit. Very similar to our domain, right? Okay, so we're gonna take a look at this. I don't think you have this on your paper. I don't think it's the next page, but we're gonna work on it together. Okay, so graphing log base 10, base 1/2, and base e. Okay, base 10 is what we work out of, right? We go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we start that process over again. We go 11, 12, 13, 14, 15, 17, 18, 19, 20. Okay, that's what we work out of normally. But you can work out of other bases. How many of y'all are in computer programming? Nobody? You are? Okay. So you've got base 2, and then you've also got a couple other things that work out of computer programming, but logs and exponentials are what you're going to use most of the time. Okay, so right here, we're going to take this function. Okay, so we've got an exponential, and we want to do it in log base 10 of x. Okay, so what are we going to do to our x and y's? Switch them, right? Okay, so, and you can just write this on the bottom of your paper. We're going to just switch the x and y's. So we're going to take the x column, write it over here in the y's, and then take the y column and write it as the x's. I don't think you have this paper. All right, so if we switch our x and y on the second one, it's going to look like this. And even when we graph this stuff, it's going to look something like this. This is going to be a rough sketch because my eyesight is the worst. Look at that beautiful sketch. Boom. Best line of your life. Okay, 4, 2, 2, -1, 2, 3, 5, 1. Oh, that should be -2. That makes sense. Dun, dun, dun. Ta-da. Oh, didn't even make it through any of those line dots. Not at all. Okay, so notice how it's a reflection across the line y equals x. Right? I draw a line at y equals x. Boom, reflection across it. Good so far? Okay, so looking at your next slide. Okay. We'll come back to this. But looking at your next slide, I want you to match up the inverse functions to each other. Okay, so you've got exponential, which means that you're going to have an x in the exponent, and then you have logs, which is going to say log in it. Okay, those are inverses of each other. Go ahead and take a moment, see if you can match up the inverse pairs, and then put the numbers down at the bottom. All right, so looking at this first one, we got 6 raised to the x. What number is the inverse function for it? Okay, we see that there is a base of 6, and there's a base of 6 on this one. So 1 and 10 are inverse pairs. Okay, what about number 2? We got 1/3 raised to the x. 7. Okay, does anybody have any other suggestions? 4. Okay, remember, we have to use the base as the number that goes down here, right? So we got 2 and 4.
Well, why is that great?
Do you see log in number 7? No. So we're missing that inverse function piece, right? So we go from exponential to log. And this is already an exponential, right? Okay, what about number 3? What about number 3? We got x to the 3rd. Now this is from last unit, right? We got x to the 3rd. If we wanted to solve this, what will we do? Algebraically. If we wanted to solve this, what would we do first? We would switch our x and y. And then we could solve for our y, right? By taking the cubic root. So which one of these looks like this? Which one of these look like this? Do any of them look like that? No. Well, is there another way we can write the cubic root of something? Yeah. We can write it as x to the 1/3, right? Well, is that an option? Yeah. Okay, so 3 and 7 are going to be inverses of each other. Okay, let me ask you this question before we go on. Was 3 an exponential function? Was 3 an exponential function? Did it have an x in the exponent? No. Okay, so it's not an exponential function, it's a cubic function. So that's a throwback to a couple units ago, right? All right, let's look at the next one. Let's start with this one, number 9. 6. But that guy doesn't have a 10 listed anywhere, right? Okay, so in logs, 10 is our most common base unit, so we just kind of drop it off because mathematicians be lazy sometimes, right? So we got 6, 9, and 6. And then what's left over? What? Okay, so we got 5 and 8. How do these two guys go together? Well, we have something called the natural log, and that's going to take us into probably the next section. We've got natural log, which is going to be log of base e. That's the same thing as saying ln. Okay, you're going to want to write that down. Natural log is log of base e, which is the same thing as saying the natural or ln. Okay. Okay, so biggest takeaways. is that the base of an exponential function has to be the base of the log inverse function. If you have a base 10, then the log of x is going to be your inverse function. And you're just going to drop off that 10. And then the natural log of base e, is also known as ln. Is going to be e to the x. What is the asymptote for this guy? What is the horizontal asymptote? I don't think you have this in your packet. Yeah. What's the horizontal asymptote for this one? Where does it approach but never touch? 0. Okay, so we're going to say the asymptote is y equals 0. What's the domain of any exponential function? Okay, so negative infinity to positive infinity. Good. Now, what's the range? Well, you just told me that there's an asymptote at 0. So that's going to be the left-hand side, right? And then up here, it keeps going on forever. So that's going to be positive infinity. Is it ever going to touch the x-axis? No. Okay, because it doesn't cross anywhere lower than 0, right? The y-intercept is going to be at 1. Is this increasing or is it decreasing? It's increasing, right?